I start the chapter Factorization, and the same chapter is there in lower classes too. And in lower classes, some algebraic formula are used to factorize any polynomial. But in class 10, this chapter has a completely different content. In this chapter, mainly two theorems are there, remainder theorem and factor theorem. Remainder theorem helps us to find out remainder when a polynomial is divided by another expression without performing actual division. And factor theorem helps us to check whether a particular expression is a factor of the given polynomial or not, and that too without performing actual division. Here I start the chapter, but before we start, I show you some simple algebraic division which you have done in lower classes. In this division, we find that the quotient obtained is x square plus 2x minus 11 and the remainder obtained is 31. This simple algebraic division I performed for a special purpose. We know that dividend is equal to divisor into quotient plus remainder, and the value is written here. You observe this polynomial which is dividend, and then divisor x plus 2, quotient is x square plus 2x minus 11 and the remainder is 31. We find here that the degree of dividend, we find here that the degree of dividend is 3, degree of divisor is 1, degree of quotient is 2, and the degree of remainder is 0. And in any equation, we know that degree of expression in the LHS left hand side is equal to the degree of expression in right hand side. And one more very important point is there, the degree of remainder is always less than the degree of divisor. So here, since degree of divisor is 1, so the degree of remainder is 0. And since the degree of remainder is 0, hence remainder is a constant term. And in this block, it's mentioned clearly that it is observed that in any kind of algebraic division process, degree of remainder is always less than the degree of divisor. And another very important point, that in our syllabus, the divisor has to be 1 degree expression, and that too is directly or indirectly. Now let us try to understand the same division process in a different way. So let's see that. Here x cube minus 4x square minus 7x plus 9 is the dividend, and it has been given the name fx. And fx means the expression is a function which depends upon the value of x. And here qx is there. Qx represents quotient, and this too is a function that depends upon the value of x. So here the dividend has been given the name fx and quotient has been given the name qx. And since we know that dividend equal to divisor into quotient plus remainder, and hence we can write fx is equal to x plus 2 multiplied by qx plus r. where fx is dividend, qx is quotient, and remainder is r, which is a constant term. Here I have said that the degree of divisor is 1, hence the degree of remainder is 0. So remainder here is a constant term. And furthermore, I find here that if I replace x with -2, then let's see during this solution what do we get. So here in the above equation I replace x with -2, and hence the equation becomes f of -2 is equal to 2 plus 2 multiplied by q of -2 and then plus remainder. Now here -2 plus 2 becomes 0. So in the next line f of -2 is equal to 0 plus q of -2 and plus r, and finally we find that f of -2 is equal to r. So it shows that when fx is divided by x plus 2, then the remainder obtained is given by the value f of -2. And this statement gives birth to remainder theorem. According to remainder theorem, if fx, which is a polynomial in terms of x, is divided by x minus a, the remainder obtained is given by fa. So here, without performing actual division, we can find out the remainder obtained by dividing a polynomial by a simple algebraic expression. Let's see some examples. If fx is divided by x minus 3, then the remainder obtained is given by f3. Next one, if fx is divided by x plus 3, the remainder obtained is f of minus 3. And if fx is divided by 2x minus 3, the remainder obtained is f of 3 by. And this we can easily understand from the above expression or equation, in fact, and that equation is here. That is fx is equal to x plus 2 multiplied by qx plus r. So in this equation, if we make this divisor x plus 2 0, then at the right hand side only r survives. So we can find out remainder when a polynomial is divided by one expression without using or without performing division. Let's see next, and the next is factor theorem. Factor theorem says that if fx, a polynomial in x, is divided by x minus a, then we know very well that the remainder obtained is fa. And if fa is equal to 0, then x minus a is a factor of fx. It means meaning is clear that if any polynomial is divided by a given expression, then in that case, if the remainder obtained is 0, then the divisor automatically becomes the factor of fx. Let's try to understand the same with a very simple example. In this example, I have taken fx as x square minus x minus 12, and we know very well that if we factorize it, then the answer is x plus 3 into x minus 4. Now let's observe this. X square minus x minus 12 is equal to x plus 3 multiplied by x minus 4. And here, if I replace this x plus 3 with 0, then the whole value at the right hand side term becomes 0. It means to make x plus 3 0, the value of x has to be minus 3. So in this complete equation, if we make this change, or if we replace x with minus 3, then the value of x square minus x minus 12 becomes 0. So here you see point number 1. F of minus 3, if it is 0, then we can say that x plus 3 is a factor of fx. And next, if f of 4 is 0, then we can say that x minus 4 is a factor of fx. Let's proceed. Here I have taken a question. The question is, find using theorem the remainder when x to the power 4 minus 3x squared plus 2x plus 1 is divided by x minus 1. And that we have to find out without performing actual division. It means here we use remainder theorem. So according to remainder theorem, first of all we assume this polynomial as fx. Now fx is equal to x minus 1 into quotient plus remainder. And here we know that fx is the dividend, x minus 1 is divisor, and qx is the quotient. Quotient we don't know, but at least we know that what quotient we get will again be a function on x. So here the name of the quotient is given q, and the parameter x says that this expression, which is quotient, is a function on x. Now in this what we do, we try to make x minus 1 0, and for that the value of x has to be 1. It means in this equation, in this complete equation, you replace x with in this equation we replace x with 1, and we see what we get. At the right hand side only r survives, and at the left hand side in the expression which is a dividend, that only had been given the name fx, and in that expression we replace x with 1 and we observe what value we get, and we finally find that the left hand side term after simplification returns 1. Hence, and that only is the value of r. So the remainder is 1, and this answer we obtain without using division process. Now let's see another process. In this second process, I am taking the value of x as 1 to make x minus 1 0, which is a divisor. So here I take the help of remainder theorem, and let's see how to write. So statement here is, since fx is divided by x minus 1, then the remainder obtained is f of 1. By remainder theorem is the reason, and nothing else we have to write. So here remainder is f of minus 1, fx, the value of fx we know, and in that value of fx each and every x has to be replaced with 1, and we simplify this and the answer we get 1. It means the remainder obtained is 1. So altogether what we did, we followed here remainder theorem, and the remainder theorem says that if any polynomial which has been given the name fx here, so if fx is divided by x minus a, then the remainder is f of a. The same way, if fx is divided by x minus 1, then the remainder obtained is given by f1, and then we find out the value of f1, and whatever value we get, that becomes the remainder. Now let's take another question. This question says, show using theorem that x minus 3 is a factor of the given expression 2x cubed plus 3x squared minus 5x minus x. And now we try to solve again using remainder theorem. So before we start, let's try to understand fx is equal to 2x cubed plus 3x squared minus 5x minus 6 is assumed. And here we know that, let's recall that equation, that is fx equal to, dividend is equal to divisor into quotient plus remainder. And in that equation we have to make the whole divisor 0. So here the divisor is x minus 3, and that is to be made 0, and for that x has to be replaced by 3 in the polynomial. And according to theorem, since fx is divided by x minus 3, according to theorem, since fx is divided by x minus 3, then the remainder obtained is f of 3. And now we find out the value of f of 3, and we get 75. You check whether this calculation is correct or not. The process only I am explaining. I hope it is correct. So here remainder is not equal to 0. Hence x minus 3 is not a factor. It is very much clear that if any expression, any polynomial, if I divide by an expression, then we say if remainder is 0, then divisor is the factor. But here we find the remainder obtained is 75. Hence at last we mention clearly, since remainder is not equal to 0, hence x minus 3 is not a factor of fx. Now we take another question, and that question is, show using theorem that x plus 2 is a factor of the given expression 2x cubed plus 3x squared minus 5x minus 6. So previous question 2 was like this only, but there we found that the remainder obtained is not 0. So the expression x minus 3 in the previous example is not a factor of the given polynomial. Here too we start the same way. We assume the whole polynomial or whole dividend as fx. And again we recall that equation, that is fx equal to x plus 2 multiplied by quotient plus remainder. And in that we have to make x plus 2 0, and for that the value of x has to be minus 2. It means according to the theorem, if fx is divided by x plus 2, then the remainder obtained is f of minus 2. Now we find out the value of f of minus 2. It means in the expression we replace x with minus 2. In the given expression we replace x with minus 2, and we simplify, and what we find, you see that the remainder is 0. Now we can say, since remainder is 0, hence x plus 2 is a factor of fx. So this x plus 2 is a factor. Let's take another question. Question number 4. Find the value of a if x plus 2 is a factor of the given expression, that is given polynomial, that is 2 multiplied by x to the power 5 minus 6 multiplied by x to the power 4 minus 2ax cubed plus 6ax squared plus 4ax plus 8. Well, again the same way we start. We assume the whole polynomial as fx, and then the same aim that in the equation, we have to replace x plus 2 with 0, and for that the value of x has to be minus 2. Now we take the help of remainder theorem, and that is, since x minus 2 is a factor of fx, then f of minus 2 has to be 0. Sorry, it's not a remainder theorem, it is factor theorem. And here you see fx is divided by x minus 2. Then according to remainder theorem, we know that the remainder obtained is f of minus 2. And we have to show that x minus 2 is a factor. Then in that case, sorry, it's already given that x minus 2 is a factor. So I can definitely say that f of minus 2, which is the remainder according to theorem, has to be 0. Now here equation is framed, and now we simplify the equation. So right from here till the last step, the calculation is going on, and we find the value of we find the value of a, that comes 4.75. So all these processes we are performing without any division. Here is another question. Find the value of a if ax cube plus 9x square plus 4x minus 10 divided by x plus 3 leaves a remainder 5. In the previous question it was said that the particular divisor is a factor, but here the question says that this polynomial ax cube plus 9x square plus 4x minus 10, when is divided by x plus 3, the remainder obtained is 5. Now let's see how to proceed. Here the same way we assume the whole polynomial taken as dividend is fx, and again the same process is there, that x plus 3, the divisor has to be 0. I missed here, 0 has to be written here, and in that case the value of x becomes minus 3. Now we take the help of the theorem. Now the theorem says, since fx divided by x minus 3 leaves a remainder 5, here actually fx divided by x plus 3, according to quotient the remainder is 5, and according to theorem the remainder is f of minus 3. The remainder theorem says here that the remainder obtained is f of minus 3, and the quotient says that the remainder obtained is 5. So here one equation is formed. At the left hand side a big expression is there in terms of x, and here x is replaced with minus 5, x is replaced with minus 3, and that is equal to 5, the remainder which is mentioned in the quotient. Now we simplify it and find the value of a, that comes 2. Here we have another question. The question is, when x cube plus 2x square minus kx plus 4 is divided by x minus 2, the remainder obtained is k, and find the value of k. So now process is completely clear to you. Again we assume fx equal to the given polynomial x square plus 2x, x cube plus 2x square minus kx plus 4, and the same way we proceed. And now theorem says that since fx is divided by x minus 2 leaves remainder k, then according to the theorem f2 is equal to k. f2 is the remainder obtained according to theorem, and k is the remainder that is mentioned in the question, hence f2 is equal to 2. Now we write the value of f2 here by replacing x with 2, and that is to be equated with k, because the question says the value of k is So here the value of f of 2 is this much, that gives remainder according to theorem, and the quotient says that the remainder is k. So the whole expression is equated to k, and now we simplify the expression and get the value of k, that comes 20 by 3. Now the same process, let's see in a different way. The common term is already there, and this method 2 says that fx is equal to x minus 2 multiplied by qx plus k, and the meaning of this is dividend is equal to divisor into quotient plus remainder, and the quotient says that the remainder is k. Now we simplify this. This whole statements we observe, that is the simplification process, because the whole equation gets converted to an equation in terms of k, because x is replaced with 2, and here we get the equation on k, and we simplify and get the value of k, 20 by 3. Let's take another question. The expression 2x cube plus ax square plus bx minus 2 leaves a remainder 7 and 0 when divided by 2x minus 3 and x plus 2 respectively. Meaning the question is, this particular dividend, when it is divided by 2x minus 3, the remainder obtained is 7, and when it is divided by x plus 2, the remainder obtained is 0. In the second case, the remainder obtained is 0. It means directly we can say that x plus 2 is a factor of the given polynomial. Well, we start now the same way. We assume fx is equal to the whole polynomial, it means dividend, and now we proceed exactly the same way. Now let's see. The case 1 says that fx is divided by 2x minus 3 and the remainder obtained is 7. So it's clearly available here, the case 1. Here, according to theorem, if fx is divided by 2x minus 3, the remainder obtained is 7. Now again we recall that main equation. In that equation, the divisor 2x minus 3 has to be replaced with 0, and for that we have to take the value of x as 3 by 2. It means in the equation x has to be replaced with 3 by 2, and here theorem says, remainder theorem says that if fx is divided by x minus 3, then the remainder obtained is f of 3 by 2, and the quotient says that the remainder obtained is 7. Now here one equation is formed, f of 3 by 2 we find out, and that is equated with 7, and the solution proceeds, and we find out the value of the unknown. But the problem here is two unknowns are there. So during simplification we get a linear equation in terms of a and b, where a and b two unknowns are there. And let's see now, after simplification we get an equation in terms of a and b. Now we go to the next part, and the next part is this one, and that says that the fx when divided by x plus 2, the remainder obtained is 0. So as I said earlier too, that x plus 2 is the factor of fx. That too could have been mentioned in the question, but the meaning is clear. So here in the given polynomial we have to make the whole divisor 0, and for that x is to be replaced with minus 2. And according to theorem, since f(x) is divided by x plus 2, then f of minus 2 is the remainder, and the quotient says that the remainder is 0. So here one equation is formed, and at the left hand side we find out the value of the expression by replacing x with minus 2, and according to quotient the remainder is 0. So this whole expression is equated with 0. Of this equation, the left hand side says it is a remainder using remainder theorem, and at the right hand side it's 0 because the quotient says that the remainder is 0. Now we simplify this and we get another equation in terms of a and b, and the remaining steps you understand very well. We have two equations in terms of a and b, I mean two linear equations in terms of a and b, and we solve it using simultaneous equation process, and we try to find out the value of a and b. And this process is very common, so this process I don't need to explain, you can easily understand. And finally we get the value of a3 and the value of b minus 3. Now let's take another question. Observe this question. The question says factorize x cube minus 7x square plus 14x minus 8, but using theorem. Well, in this case, no hints is given, nowhere it's mentioned that a particular thing is a factor of this expression, or if this expression or polynomial is divided by a particular expression, then what remainder is obtained. So in this case, what should we do? We, on the basis of trial and error method, we try to put the value of x in the given polynomial, and we find out what value is returned by the expression when we replace x with some numeric value, and that is a pure rough process. And if the moment we find that the expression returns 0, then from there onwards the solution starts. So here you see, after doing all those rough work, obviously somewhere else, because that cannot be the part of the solution. Well, after this working out, I found when the value of x is 1, or when x is replaced by 1, then the expression returns 0. So according to theorem, we find that if f1 is 0, then we can say that x minus 1 is a factor of fx. And fortunately, by putting the value of x as 2, or by replacing x with 2, the expression we evaluate, the polynomial which is the dividend, we evaluate, and again we find it comes 0. So again we can say here that since f of 2 is equal to 0, hence x minus 2 is a factor of fx. Again factor theorem. And the third case, again we find that if x is replaced with 4, then the expression, I mean the dividend, returns 0. So again we can say, since f4 equal to 0, then x minus 4 is a factor of fx. Now overall, see the observation, this dividend has the degree 3 because it starts with x cube, I mean higher power is 3, so this expression is of 3 degree. Hence it's clear that total of maximum of 3 factors can be available of this expression. So let's see the last few lines. So from the equation 1, 2 and 3, we can say that fx is equal to x minus 1 multiplied by x minus 2 multiplied by x minus 4. But the solution is complete, but this particular process is not suggested. The reason behind is if three different factors are there and the factors too are in simple form, then very easily by trial and error method we can find out all the three factors. But the problem is, if the factor is in a complex form, suppose instead of x minus 1, if the factor is 2x minus 3, then we may fail to guess here that if we put the value of x as 3 by 2, then the remainder then the value of the expression we get 0. So that's tough. So this process is hardly suggested. And another reason for not suggesting this process is, if any one of this expression occurs twice in the polynomial, then we fail to understand, or in fact we fail to follow this process. So the common suggested solution is this one, that is method 2. And in this solution we honestly follow factor theorem to find out just one factor. So here, by putting the value of x as 1 in the polynomial, we find that the polynomial returns 0. So we can say that fa is 0, f1 is 0. So since f1 is 0, then we can say x minus 1 is a factor of fx. So here it's written, now divide fx by x minus 1 to find a quotient. In fact, one factor somehow we have to find out using theorem in this type of quotients. And we find that in this type of quotient, once one factor of simple form is always there, so that by using theorem we find out at least one factor. So in this polynomial, x cubed minus 7x square plus 14x minus 8, one factor we found out, that is x minus 1. And now we come down to the simple common process to find out other two factors. And let's see how to find out other two factors. Here two different processes are mentioned. First process is a simple division process, which is a very common process. The polynomial x cubed minus 7x square plus 14x minus 8 is there, and that I am dividing by x minus 1. A very common division process I am following, and I found that the quotient obtained is x square minus 6x plus 8. Now this x square plus 6x plus 8 we factorize, and this simple factorization called trinomial can easily be done by splitting the middle term, which you have done in lower classes 7 and 8. 7, 8, class 7, class 8, class 9, this type of quotients are there to factorize a trinomial, in which we split the middle term. The process you know, so that process I am not explaining here. I am simply factorizing it. So last block you see, final common steps. In this final common steps, we solve the quotient, in fact we factorize the quotient obtained in the division, and we get the value x minus 2 multiplied by x minus 4. So here you see the whole the dividend was x cubed minus 7x square plus 14x minus 8, and using factor theorem we found out one factor, that is x minus 1, and that factor x minus 1 we extract from the polynomial, and we find the quotient obtained is x square minus 6x plus 8. Now this quotient obtained x square minus 6x plus 8 is further factorized, and we get the factors x minus 2 and x minus 4. So altogether the factors of the polynomial are x minus 1, x minus 2 and x minus 4. And the question simply says factorize the given polynomial. Hence, after getting answer, we are bound to write the answer in product form. Here one process we followed to extract x minus 1 from the given polynomial, and that division process we understand. But this particular task is done here in a different way, so you should take interest in understanding this method too. And I find that this method of extracting x minus 1 a factor so that we get the remaining value as quotient, this process is much better than the division process, that I feel. If you practice, you too can easily understand how to write solution this way. In this solution, what we do, in the polynomial, in the given polynomial, which is a dividend, that is x cube minus 7x square plus 14x minus 8, we try to split both the middle terms, and here the two middle terms are minus 7x square plus 14x. And how to split this, that in details I'll discuss later. But here too you can understand, and let's try to understand that. First of all, the first term of this polynomial is x cube, and we keep in mind that x minus 1 as a factor, which we have already got using factor theorem, we have to extract from this polynomial. So first term is x cube. Now we say what should be the partner of x cube so that this pair x cube and minus x square returns x minus 1 a factor. So I find that if x cube is there, then its partner should be minus x square, so that in this pair, if we take x square common, in this pair, if I take x square common, we get x minus 2 a factor, and that is done in the next line. I will come to next line. Now next is where from this minus x square has come. Then we can easily say that by splitting minus 7x square, we get one term minus x square, and then the remaining term is minus 6x square, so that these two together becomes these two together becomes minus 7x square. Clear? Now, so first pair is complete, x cube minus x square, and I know that this pair gives a factor x minus 1, and that only was the need. Well, now minus 6x square is left. Now we try to find out the pair for the partner for minus 6x square, so that this pair returns again the same factor x minus 1. So I find that plus 6x I have to write, and now let's observe this pair, minus 6x square plus 6x. If I take common, we find that it gives a factor x minus 1. So this part also is done. But the problem is where from this plus 6x comes. Then again we can say that this plus 6x has come by splitting minus 14x. And now this, plus 14x. We can say that plus 6x is obtained by splitting plus 14x. Now from plus 14x, one value plus 6x is available. Then what is left? That is plus 8x. So that these two together becomes plus 14x. Now 8x is left. Here you see the first pair is complete, which first pair x cube minus x square is complete, which gives a factor x minus 1. Second pair minus 6x square plus 6x is complete, which again gives the factor x minus 1. Now at last plus 8x is there, and the last term minus 8 is there. Sorry, here by mistake plus sign is there, it has to be minus. And now from this last pair, here something is missing. we understand what it should be. 8I take common and x minus 1 is left here. So here something is missing in this part, because this part is 8x minus 8, not plus 8. So here in the last part is 8 is taken common and x minus 1 remains there. So from all these three terms, x square multiplied by x minus 1, minus 6x multiplied by x minus 1 and plus 8 multiplied by x minus 1, we take x minus 1 common, and what remains is the quotient x square minus 6x plus 8. And then after that, the process is available here, the common process which we had discussed, that is this process. And then finally we complete the solution and the answer comes same, x minus 1 multiplied by x minus 2 multiplied by x minus 4.
Thank you for watching this video patiently. I'll come with some more questions in the next video. So you take this chapter seriously and prepare each and every bit. Thank you very much.